The whole number is called a couple of things. The atomic number, or the proton number, or the electron number. For the electron number, it does work as long as the atom is neutral. Okay. And the decimal number is called the molar mass, or the atomic mass. Atomic mass can also be called the atomic weight. So how are they different? They're different in terms of the unit. So the molar mass is measured in gram per mole, but the atomic mass or the atomic weight is measured in AMU. Good. So now if someone says, what is the atomic number of silicon? What would you say?
14.
And what's the molar mass of silicon?
28.09.
Good.
But the one here, okay, so one question. The molar mass and the atomic mass, so they're measured in grams per mole and AMU. Are they the same in terms of
Same exact
numbers?
number.
Same exact number.
Yeah.
Okay.
Same exact number. Very good. Now, as you can see from left to right, we have 18 groups. Okay? We have 1 all the way to 18. We have 18 groups. And if 2 elements are in the same group, they would end up with having similar chemical properties. Okay, and so for example, Mg and Sr, or Ca, or Be, Ba, or Ra, they're all in group 2. So groups are going to be vertical.
Yes.
Vertical. Now, if you're going to be in the same group, you must have similar chemical properties. So Mg and Be and Ca, Sr, Ba, and Ra all have similar chemical properties. Why? Because they have the same number of valence electrons. Valence electrons or valence electrons are found in the outermost shell, which you can also tell from the periodic table. Now, so same group means similar chemical properties because they have the same number of valence electrons. How do we find the valence electrons? So group 1 has 1 valence electron, 2 has 2 valence electrons, group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and group 18 will have 8 valence electron, with the only exception being helium, which has 2 valence electrons. So helium has 2 valence electrons, but the rest of group 18 will have 8 valence electrons. So we can also tell the valence electrons based on the group number. Good. You see, I skipped groups 3 through 12 because they are not always very simple to talk about. What else can we tell about the periodic table from the periodic table itself? Let's see. We can also tell the charges. The charges are referred to in chemistry as the oxidation numbers. Exactly. Where a group 1 is a +1, group 2 is a +2. Aluminum is going to be a +3. Oxygen is going to be a -2 for almost all the cases. S is a -2 for a lot of cases. Group 17 will be -1 for the most cases. And from groups 3 through 12, I can confirm for you that zinc is a +2, that cadmium is a +2, and that silver, which is Ag, is a +1. So we can also tell oxidation states for a lot of elements based on the periodic table. Okay, we can also tell which one is metal, which one is non-metal based on the periodic table. So I will highlight for you the non-metals. So if it's highlighted in yellow, it's going to be a non-metal. So all of these so far will be non-metals. These are all going to be our non-metals. They're not that many. Not many. So if it's highlighted in yellow, it's going to be a non-metal. Now, if I use a different color, let's say right now, if I use this color, that's going to be called a semi-metal, which some might call it a metalloid.
Yeah, metalloid.
Metalloid. Only a few of them will be that. So a boron, silicon, Ge, As, Sbte will be semi-metals. And the rest that I have not highlighted will be metals. Okay. So the unhighlighted are metals. Okay. So we can also tell this from the periodic table. Very good. What else can we tell? Let me show you. So group 1, with the exception of hydrogen, are called alkali metals. And they tend to lose 1 electron and they gain a +1 charge. Group 2 are alkaline earth metals and they are +2 charge. From 3 to 12, they are called transition metals, whose charge is variable for almost all of them, except for the zinc, cadmium, and silver, which we already took care of, right? Good. So transition metals. Okay. What other colors can we use? Group 17 is going to be the halogens. Okay. And then finally, we're going to be having group 18. I don't include OG because no one talks about it in the AP. It's a bit new. So this will be basically the noble gases. Okay. Good. Let's tell more things only based on the periodic table. There is something called a period in the periodic table, which is basically the rows, which are horizontal. Okay, and we have 7 periods. 1, 2, 3, 4, 5, 6, and 7. And the number of the period tells you how many shells we have. So for example, if we're talking about elements in the 3rd period, they have 3 shells. So sodium would have 3 shells, Mg would have 3 shells, all the period 3 would have 3 shells. But then if I go to period 5, they would all have 5 shells. So essentially the size of the atom will increase as we go down. Good. Good. Okay, let's tell more things about the periodic table. Do you know what electronic configuration means?
Yes, I do.
Okay, so let me give you a small trick. Group 1 has to end with S1. Group 2 has to end with S2. D1, D2, D3, D4, D5, D6, D7, D8, D9, D10. P1, P2, P3, P4, P5. Here it's going to be P6, and helium is going to be S2. Now, one thing you have to note here, though, that D4 and D9 have a special rule. Like, even though I say it has to end in D4, it should not end in D4. Why is that? Whenever you have S2 and D4, this is not acceptable. And whenever you have S2 and D9, also not acceptable. If you have S2 and D4, the S must be able to donate 1 to the D to make it S1 D5, to make it S1 D10. So technically, even though here I say it's D4, it should be a D5 by taking 1 from the S. And technically, when I say here it's a D9, I must be taking 1 from the S to make it into a D10.
Okay.
Good.
And that is in all of the cases of D4 and D9.
Yeah, whenever there's a D4 and D9. Okay, by the way, this rule applies for an atom, right? So atoms can have S2, D4, S2, D9, but we're not supposed to have those. We're supposed to ultimately change them into these guys. Good. So now we learned almost everything we need to know just from the periodic table. Okay? That's very good.